The first recipient of the Engineering Medal for Engineering Excellence is Dr. Robert Delatolla.
My name is Rob Delatolla. I'm a professor at the University of Ottawa. I'm in the Department of Civil Engineering. My academic career started at the University of British Columbia, proceeded to get a master's degree in civil engineering from the University of McGill. I then worked for a couple of years in the city of Montreal. I then decided to go back and do my PhD in chemical engineering at McGill University, focusing on biological treatment of wastewater. And subsequent to that, professor here at the University of Ottawa for the past 12 or 13 years. The biggest engineering challenge that I faced throughout my career was really pivoting my group to look at this disease target in wastewaters. And we pivoted at a time when we were in a pandemic. We actually developed or optimized a method to actually look within wastewater to track and quantitate or quantify or measure the concentration of the disease target associated with COVID-19. We also, working with the Children's Hospital of Eastern Ontario, we actually developed methods to look at that genome and that genetic code to actually discern whether that signal was coming from a certain variant of concern, from everything from Alpha, Delta to Omicron and all the sublineages, so that we're able to actually monitor and track the virus in the sewer system. We were looking at wastewater, we're looking at the microbial components of it, but we're looking at it totally on the other side of the coin. We were looking at the beneficial organisms. So in a way, we weren't looking at disease targets at all, but we were doing methods in the lab that were very similar to what we needed to do to track disease targets in wastewater. I think that we have just really scratched the surface of a new technology. So looking at wastewater as a portal into the health of a community, I think we've been able to build a science rapidly within 2 years during the pandemic. And I really would like to see that expanded to other diseases. So we've learned throughout the pandemic that there are health inequities across this country, and that was exacerbated during the pandemic. And we wanted to develop a tool not only for the major cities of this country and of the world, but a tool for those communities so that we can sort of maybe address some of those health inequities and sort of provide a new way, an economical, an autonomous way for them to learn about the health of that community and how it could be improved. So the question is, how is, the genetic code of COVID-19 ending up in the wastewater? And we shed it. Whether you use the washroom, it's fecally shed, so we know it's in human stool. So it ends up into our premise piping in our homes, and then ends up into our large infrastructure in our cities. And we go at different levels, sometimes into the sewer system, sometimes all the way at the end where all the pipes combine at the wastewater treatment plant. We go there and we get a picture of the whole city, or we go into certain stores and we get a picture of a neighborhood, or we go right in front of a building, for example, a long-term care facility, and we get a picture of how much COVID-19 genetic materials right in that long-term care facility on that day. What you're seeing in this lab and what Jianjun is doing and Shen is doing is they have that concentrated RNA, and now out of all the RNA, everything that we actually, all the genetic code that we excrete that is found within wastewater, they're isolating the genetic code for that specific virus. And they're able to output what is the concentration basically of that viral genetic code within our wastewater every day.
In recognition of his work to develop a method to measure SARS-CoV-2 viral genetic signal in wastewater, Dr. Robert Delatolla is a worthy recipient of the Engineering Medal in the Engineering Excellence category.